Let me record this class. Class is recorded now. And anyone is ready?
Here's my screen.
Yeah.
So I'm presenting two questions. The first one is from chapter 8, 14. A certain component is critical to the operation of an electrical system and must be replaced immediately upon failure. If the mean lifetime of this type of component is 100 hours and its standard deviation is 30 hours, how many of these components must be installed so that the probability that the system is in continual operation for the next 2000 hours is at least 0.95. First of all, we convert the 0.95 to t. It's from the normal distribution.
You mean to find
Yeah.
a z-score corresponding to 95%.
So from this table, we find 0.95 and convert it to v of 1.65. And then we collect all the data. We have mu equal to 100. We have sigma equal to 30, and we're looking for the n value. And the xn is the sum of x1, x2, all the way to xn. And we use, what is that called? We use central limit theorem. And then we just plug in, do the calculation, and then we got this, but we can rewrite this to this term. And we know this is equal to 1.65. And we got this, but I'm not really sure how to calculate it in how to calculate it algebraically. So I just plug in the n value, and when n is equal to 23, the probability would be at least 0.95. That's the first question. The second question is from chapter 6, 54. The Z1 and Z2 be independent standard normal rundown variables given x equal to Z1 plus Z2 and y equal to Z2 minus Z1. So that x and y are independent normally distributed rundown variable with mean 0 and variance 2. In order to show they are independent, first of all, notice Z1 and Z2 are independent, and follow the proposition 2.1 is right. 2. Yeah, follow this proof, we can show x, y are independent, and then it's normally distributed because Z1 and Z2 are normal rundown variable. And we show mean is 0 and variance is 2. Since Z1, Z2 is standard, that means the mu for Z1 is 0. Also for Z2 is also 0. And the variance for Z1 is 1, Z2 is 2. And to calculate the mu for x, we just add those two. So mu1 plus mu2, that would be the mu for the x. So it's 0. And for the mu for the y would be mu2 subtract mu1, that's also 0. And since they share the same variance, that would be sigma, that would be variance 1 plus variance 2. That gave us 0. Yeah.
Nice. Nice.
Thank you.
All right. Thank you. Anyone has any questions? If anyone has any questions, feel free to stop me at any time. The two questions are very nice questions. Shit. All right, who's going next?
Can you see my screen?
Not yet. Yes, now.
I don't know if I did it correct, but I'm gonna try it. So I chose 8.2, and it says from past experience, a professor notes that the test score of a student taking her final exam is a random variable with mean 75. Given upper bound for the probability that a student's test score would exceed 85. So the mean is 75, the probability X is greater than 85, and we know the Markov, I don't know if I'm mispronouncing that, inequality. So you enter the values into the equation. So the probability of X being greater than 85 equals 75 over 85, which is approximately 15 over 17, and that gives you 0.8824.
Yeah, perfecto.
And then I did 15. I gotta find it. 14. Where'd it go? Right here. So an insurance company has 10,000 automobile policyholders. The expected yearly claim per policyholder is $240 with a standard deviation of 800. Approximate the probability that the total yearly claim exceeds 2.7 million. So the mean is 240, the variance is 800, N is 10,000, the average equals 2.7 times 10 to 6 over 10,000, you get 270. The probability of the mean of x's is greater than 270 equals the probability of the mean of x's minus the mean over the variance divided by square root of n is greater than 270 minus the mean over the variance divided by the square root of n equals the probability of z is less than 270 minus 240 over 800 divided by the square root of 10,000. And that gives you probability of z is less than 3.75 equals 1 minus 1 minus the probability of z is less than 3.75, and that equals 1 minus 0.99991, which gives you 0.00009.
Okay, the textbook use a phi. Once you convert into z-score, the textbook use a phi. So you don't use the same probability, the variable p. But you did it right. I think you did it right. I don't see anything is wrong.
Yeah, I went to tutoring, so I don't know if they showed me a different way. I didn't really look at the textbook. I'm sorry.
Oh, I see. But you understand what my point is?
Yeah.
So you're converting x right into standard normal. So you have a normal, you convert into standard normal, so you can check with the standard normal table.
Yeah.
Okay, right. Did we do continuity correction? It's okay. Gia, it's okay. Thank you. That's Catherine. All right, who's next?
Hi, Professor. Good evening.
Good evening, Kara.
Professor, I am going next.
Okay. Yeah, Aryan is asking, how does continuity correction work? I didn't emphasize on that, so don't worry about it, okay?
It's when you use continuous distribution to approximate a discrete variable. Like if you have like dice rolls and you're approximating the value, those are discrete values like 1, 2, 3, 4, 5. So like if you are using the central limit theorem on that, if you have like, you're doing like x greater than 5, you would add 0.5 to make up for the fact that it's a discrete variable. And like if it's less than 6, you would subtract 0.5. If it was less than equal, you would add 0.5. If it's greater than equal, you subtract 0.5.
Thank you, Tom. Thank you.
Professor, can you see my screen?
Yes.
I'm going to present 8.4. Let x1 to x20 be independent Poisson random variables with mean 1. A part is use the Markov inequality to obtain a bound on probability into summation 1 to 20 xi greater than 15. B part is use the central limit theorem to approximate probability into summation 1 to 20 xi greater than 15. So for part A, let x1, x2, x1 to x20 be independent Poisson random variables with mean 1. This implies mean E into x is equal to 1 and variance x is equal to 1. The Markov inequality is probability into x greater than equal to a, which is equal to less than equal to a into x over a. So a into summation I is equal to 1 to 20 xi is equal to summation I is equal to 1 to 20 into xi. So after putting the value we have, which we have from the questions, 20 e into xi, 20 multiplied 1 is equal to 20. So for Markov inequality, we will put the value um, which we got above 20. So it will be 20 over 15. So finally we get that, hence probability into summation 1 to 20 xi greater than 15 less than equal to 4 over 3. So for part
Great.
B, use the central limit theorem to approximate probability into summation 1 to 20 xi greater than 15. The variance is equal to 1 implies sigma is equal to variance x under root is equal to 1. So sample size n is equal to 20, it is given in the question. So probability into summation 1 to 20 xi greater than 15 is equal to probability into x minus n mu over sigma under root n greater than 15 minus n mu over sigma under root n. So after putting the value, we will get the z value which will be greater than minus 1.11. Probability into z greater than minus 1.11. So from the table, we will get that the answer 0.8643.
Nice. Thank you. I hope you guys don't have allergy. Horrible. Okay. So we have Xiu Yu, Tom, and yeah, Xiu Yu and Tom, right? Ayat. Okay, let me make a presenter.
Hello.
That's Tom. Okay, you change your color.
Yeah. I'm trying to see if I can highlight. Do you see this?
Yeah, suppose the daily change.
Okay, suppose the daily change of a price of a stock is a random variable with mean 0 and variance s squared. That is, yn represents the stock price on the nth day, then yn equals yn minus 1 plus xn for n is greater or equal to 1. x1, x2 to xn are independent and identically distributed random variables with mean 0 and variance sigma squared. Today's stock price is 100. If sigma squared equals 1, what is the probability that the stock's price exceeds 105 after 10 days?
Mm.
Given y0 is equal to 100, and for the xn variables, we are given variance equals 1 and mean equals 0. So we find probability of y10, the 10th day, is greater than 105. So I convert that to less than or equal to 105. And it's a continuous variable, so you would not use a continuity correction because the price is not like an integer. It can be like 103.9, for example. So this would not be a case where you use continuity correction. I wrote out central limit theorem states sequence of independent and identically distributed random variables with mean mu and variance tends to the standard normal. As n goes to infinity, and is something like there's a 10th day here, so it's just approximation. So for each y sub n, we have it's equal to the previous day plus xn. So that's like a recurrence relation. And we have y10 equals y9 plus x10, which equals 100 plus x1 to x10. And we can calculate the expected value of y10 using expectation formula. The linearity of it, where we take out each value, and we get 100. And for variance, similarly, we get 10s squared after taking out all the variance for each to get 10s squared as our variance, and we get our standard deviation is s, which is radical 10 after you take the root of each side and plug into the formula of the central limit theorem.
You get, so hold on 1 second, Tom. You get 10 of them because the first one is 0, right? Shouldn't you get 9 of them? Oh, you start with x0.
You start with 0, and we're given
y0, right.
S squared for each x term in the problem is equal to
It's
1.
10 of them. Yes.
So we have 10s squared. Then to find the standard deviation, we take the root of both sides to get radical 10. So we plug in here for sigma, and we plug in our mean here for 100. And n here is actually 1 as far as the central limit theorem n goes, because we only have 1 day that we're observing for y10. Right. So we get 1 minus the z-score of this value. It's for 5.71%.
Nice.
Oh, and I can also show the table for continuity correction. I wrote it down somewhere.
Yeah, go ahead.
So if you have a discrete variable such as the values of a dice, and you're applying the central limit theorem, you have to use the continuity correction for these values, because you're using a continuous model for a discrete values. So you're gonna get an inaccuracy if you don't adjust it. So like the way I remember it is, if it's like greater than the value, you add 0.5. If less than, you subtract. If you have less than equal, you kind of do the opposite where you plus, and greater than equal, you do the opposite direction where you subtract 0.5. That's just how I remember it.
Yeah, I don't remember exactly, but I think you're right. And it sounds logical as well. Thank you, Tom.
Okay, I'm finished.
Okay, thanks. I think we're left with Xiu Yu and Ayat.
Okay, I go next. Can you see my screen?
Yeah.
So my question is from chapter 6. So it's 46. The joint density of x and y is fxy equal to cxyq when x is greater than 0 less than 1 and y is greater than 0 less than x to the power of 1 over 4. Find C and the conditional distribution of x given y equal to y. First, I use the joint density function, which is 2 integral of fxy equal to 1 to find C. So
usually we see double integral.
Okay, double integral. So first, I take out cx and find the integral of yq. So it's equal to y to the power 4 over 4, and I take out 1 over 4, left y to the power 4. So use y equal to x to the power of 1 over 4 minus y equal to 0, so which will get x. So I take out c over 4 to find the integral of x squared. So the integral of x squared, which is xq over 3. So I use x equal to 1 minus x equal to 0. Then we will get, which is c over 12 equal to 1. So c is 12 in here. Then we need to find the conditional distribution. We use this formula. And we need to find the fyy. Is that? Which is the integral of fxy dx. And in here, we need to find exactly an interval of x. So by the question, we know that x is between 0 and 1, and y is between 0 and x to the power of 1 over 4. So I times the power 4 into this, then we will get x is between y to the power 4 and 1. So the interval of the integral is this. So to find the integral of 12x yq, I take out 12yq and find the integral of x, which is x squared over 2. Then plug in x equal to 1 minus x equal to y to the power 4. Then we will get 6yq times parentheses 1 minus y to the power a. So use the conditional distribution formula, which is 12xyq over 6yq times 1 minus y to the power a. Then we will get the answer is 2x over 1 minus y to the power a.
Okay, so how did you get a x in between y to the first power until 1?
I times
Draw a picture?
hmm?
Did you draw a picture of it?
No, so first I make a I write the answer, but I look at the answer on the textbook. It's not the answer I get, and I find that if I times the power 4 into this 2 to find the integral of y to the power 4 and 1, that's the answer.
Right. I thought you draw a picture of it. This is like, okay, that's fine. I was trying to make picture. I was trying to draw a picture to see. All right.
Okay.
All right. Very nice. Thank you. All right. And yeah, Ayat.
Did you hear me?
Yeah.
Okay, the question 8.10. An elevator has a capacity of carrying 8 people. Safety standards permit only one instance of overload per 1,000 trips. Passengers using the lift are assumed to have normally distributed weights of the mean 80.1 kilogram and the standard deviation 15.6. Find an approximation to the value of this maximum. Let X be a total weight variable that represents the total weight of 8 people. One instance in 1,000 trips allowed means that the probability of X more than maximum weight equals to 1,000. That's right here. So apply the formula. Probability of Z more than maximum minus N. It's a number of people multiplied by mu. It's a average weight of the people of the person over sigma multiplied by square root of n equal to 1,000. From the table, we know that this probability that equals to 1,000 is when z more than 3.8. So I equalize left side to the 3.8. We have all variables, and I multiply only the maximum, calculate the maximum, which is equal to 776.7 kilogram.
Interesting question. All right. Thank you. It's Ayat. have no idea how was my speaker was muted. Oh, because I switched my headphones. Yeah, Darius, are you talking?
Hello?
Oh, yes, now we can hear you.
Oh, okay. All right. So this is 8.17, redo example 5B. So we're just doing the approximate, turning to approximate normally distributed from example B. So pretty much we're just applying the central limit theorem. It gives us our mean and variance, everything that we need. So we just plug that in. And I did, to help me calculate phi for this, I did use like Wolfram to help me calculate that. So yeah, it derives approximately of a phi of negative 4.04, which
Hold on a second. Hold on a second. Let me understand this. So we're just trying to see the upper bound is reasonable.
Mhm.
Okay. All right.
Yeah.
Okay, go ahead.
Oh, okay. But yeah, the example pretty much gives everything. So just plug it into the central limit theorem and calculate it out, and it arrives to approximately 0.
Oh, just keep, oh, okay. So expected value is 50.26. That's how you calculated, or you get from 5B?
Yeah. Oh, yes. No, it's from 5B. Yeah. The mean and the variance is from the example. It's really big example, so I didn't copy the whole example. I just copied the problem.
I see. Okay. All right. Thank you. Oh, yeah, you can present another one if you want to. Oh, how many problems do we have to solve in homework 8? 10. Because it will only cover 8.2, 8.3. Choose 5 from each. All right, I think I have given everyone credits. If I missed, let me know. So the presentation credits goes from 50, 70, 80, and Jill has the highest, 240. Okay, and I basically have nothing to say. If anyone has anything interesting to talk about, when did you come to America? Catherine, who come to America? Catherine, whom are you talking about too? Who's not in America? Ayat? Ikera? Serious? Someone taking this course from outside of the state? Oh, what do you mean? Oh, you mean when did I come to America? Ah, long before. Probably before you were born. Probably before you were born. I came here to study. Yeah, probably before you were born. 1996. How many years ago? 1996. 27 years ago. Is that true? Yeah. 1996, September 6th. So it's, yeah, it's almost 27 years. My goodness, it's crazy. I spent the longest time in America, in New York. So I came to New York, I stayed in New York until now. Kate Catherine was too. But you were born. So when I came here, you were born. You're 2 years old baby. Many of you probably have not born yet. No, I was a computer programmer. So my first degree was computer programmer. I worked with C, C++, and Java. We use Java a lot. But then I quit my job because I have 2 kids. I quit my job, stay home with my 2 kids. Then when my 2 kids, you know, grown up, they don't like me. They feel I like a policewoman, always on their back. So I don't want to ruin the relationship because they have to play piano, they have to go swimming, they have to do my homework. I just put a lot on them. So I think it's just too much for our relationship. So I went back to school and I said, okay, what could I do now? I don't want to be a programmer anymore. So I wanted to be a teacher. So I went back to see, oh, how can I be a high school math teacher or some computer science teacher or maybe Mandarin teacher? I can teach Mandarin. Then I find out I have to take a 15 credits, something called institutional credits. So they can recommend me to take the teacher's lessons exams. So I did that, and I went to Queens College. I did that, okay. But then I became a high school math teacher. Was a horrible experience. At that time, because I went back to school for these 15 institutional credits, somehow my love for mathematics came back. When I was young, I was always good with mathematics, and I always loved to solve mathematical problems. And the love for mathematics came back. So one of my teachers, Professor Kramer, he graduated from Harvard. He's very smart. He's a Jewish guy. And I like to talk to him because I would ask him, you know, I don't like to do this. What should I do? Then one time he said, so by then I finished all the credits for master's degree in mathematics. He said, why don't you go for PhD? I said, am I too old for PhD? I'm going to my 40s. He said, no, not at all. He said, you're very good with mathematics. You understand what's going on. He even named one thing I figured out as a chance theorem. You know, he put on the final exam. So he encouraged me. So the whole summertime, so I quit my job. I really hate the experience to be a high school math teachers. I think all the math teachers, they're teaching students wrong stuff. In the teacher's lounge, I always argue with them. I said, you cannot teach students this way. You confuse them. They teach students to change percentage by saying, just multiply by 100. I said, that's such a wrong way of thinking about it. I said, can you just multiply 100 with an expression? I said, no, you can only multiply by 1. And this 1 is 100 by 100, 100 over 100. But in any case, I did not like, you know, to stay in the high school. I tried middle school, I tried high school. None of them I liked it. So the whole summer, I quit my job. The whole summer, I stayed home. I took, you know, prepared for GRE exam. So I had a GRE exam end of the summer, and I applied I applied for the graduate center in Manhattan, and miraculously, I was accepted. I didn't expect to be accepted, but I was thinking, okay, I'll apply more and more. I'm gonna just go for my PhD in mathematics because I think everything is so interesting. Abstract algebra, got my heart, and the topology got my heart, and everything in mathematics just makes so much sense for me. And yes, so I graduate, and yeah, even when I was doing my PhD, there are 14 students from all over the world, from Cambridge, from Harvard, from Columbia, from NYU, from all the good schools. And you know what? In the end, only 6 of us graduated, and the others either quit or I don't know where they were nowhere to be found. But it's hard work. It's 6 years. The PhD program is 6 years. It is extremely hard. I have my cohort cry to me. I don't know if he ever finished. I lost contact with them. He cried to me. He said, I don't know how you did it. By the way, I'm a single mother. He said, you're a single mother. You raised 2 kids, and you can still do this. I said, because I enjoyed it. And it's hard, but I loved it. Do I ever get stressed? Of course. The 4 core exams, something called a qualification exam. Oh, some students were kicked out of the program because if you cannot pass these 4 cores, you are kicked out. You are kicked out of the program. And it's a hard journey, but anything in life is hard, it's worth it to try. It's worth it to get. It's worth it for your effort if you have the love for it. Aya is asking me, can you explain the reason for resigning from your job in computer science again? Oh, I have 2 kids. I'm sorry, that's my daughter. He just came by. Let me put my earbuds on. Yeah, the reason I quit my job is because I had a nanny. By the way, I mentioned earlier, I'm a single mother. So my nanny, I had a nanny, what she does, she likes to put my 2 kids in front of TV. And I don't like that. I talked to her, I said, you ought to let them do this, do that. But she just cannot do that. She just, it's very hard for her. There's no way for her to achieve that goal. And yeah, and I guess on the other side, I have saved some money. So I think, 2 kids are more important. Their future are more important. So I quit my job. I send them to school. I pick them up from school. I send them to swimming practice. I send them to piano practice, to piano teacher, and then come back home. They have to, each of one of them have to practice piano for 1 hour at least. They have to read 1 book per day. They have to write me, a reading report. So I give them extra work, mathematics. Have you read the book, A Tiger Mother? I was like that kind. So sometimes my daughter complained about me. He said, you never cared about my happiness when I was a child. I said, I'm so sorry. That was not in my mind. I was thinking your success is in the future. Your happiness is in the future. You have to get into good school. You have to get a good job. That's the only thing in my mind. Because I had no support in America. All my family is in China. And their father, he just doesn't care much. He just goes to anywhere he wants. I think after kids, does that mean I have to switch to a math degree? If you love mathematics, if mathematics speaks to you, all right? I think we're so different. We are all good at something. We're also, so bad at something else. 我好厉害，好伟大。No, not at all. I think all of us are marvelous. You know, we are intelligence. All of us intelligence. Of course, I remember Chinese. Chinese is my mother tongue. I forget. I'll never forget. Yeah, I speak my mother tongue most of the time. I speak English whenever I have to. You guys, you know, Tom once was asking me about some questions, and some other of you asked me some other questions. I think in life is short, but life is marvelous. I'm a very religious person, by the way. I don't believe life is only for this period of time. It's only for the flesh and bones. I believe life is for eternal. But somehow, you know, this time is short. Live on this earth is short. Oh, thank you, Yongxin. This life is short on earth, but somehow we have to make the best of it. How to make the best of it? You know, do something we love. Sometimes I think people thinking too much about, you know, if we can make enough money. And I think I can guarantee you one thing. If you stay with something you really love, money is not a consideration. Money will come along. You will, you know, you will have enough money to support what you love. That's America, you know. That's the beauty of America. Yeah, do something you love. You believe in the Big Bang Theory? You know, because we believe, I'm a Christian. I'm actually a member of the Church of Jesus Christ of Latter-day Saints. People call LDS, or some other people, because we read the Book of Mormon, some other people, you know, probably call Mormons or something. We believe God created the world. How did he create it? We don't know. It could be, you know, something like the Big Bang Theory. I don't know. And each one of us, you know, is an intelligence. That means a lot. That means we have a potential to be just like a God. You know, we can learn anything. We can learn, and we can reason, and we can you know, we can do logical stuff. We can derive. So our power is far beyond we realize it. Oh, as a professor, little money. You can't believe it. It's less than 100,000 per year. You know, that's yeah. Anyway, I think you guys are fabulous, especially those of you trying so hard to present every time. And I could see some of you just came to this country by your, you know, speaking, by your English speaking. But so what? All right, every one of us has advantage, has disadvantage, and you know, just use your advantages, and yeah, you will be successful in life. All right, anything else? And you don't have to be here listening to me, all right? And if you have no further questions, and you are free bird for tonight, and I see you on Thursday. Have a good night. Oh, the final probably have to be in person, right? Because it's required by the, is required. Oh, I'm trying to make less, I'm trying to make like from 10 to 12 questions. From chapter 6, from chapter 8, you only have to do 10 questions. From chapter 6, let's figure out. From chapter 6, how many we covered? It depends on how many sections we covered. Each section you choose 5 questions. Exam is cumulative, yes. Chapter 6, let's see. Chapter 6, how many? Chapter 6, we covered a lot. Let me share my screen with you. Oh no, don't want to share this. I want to share something else. Okay, for chapter 6, we have covered 6.1, 6.2, 6.3, and 6.4, 6.5, 6.7, 6.8. So 6.7. 6.8 is optional. 6.7. So how many? 1, 2, 3, 4, 5, 6. You have to choose 30 questions. Yeah, I may allow you to make a cheat sheet for formulas. All right. For formulas, because it's difficult to remember all the formulas. But not a cheat sheet for writing down questions, like examples. Okay. All right. Any other questions? Chapter 6 is not due yet. Chapter 6 is... Chapter 6 is due. Chapter 6 is due. But you can still submit. You just don't receive full credits, but you still receive most of the credits. You still get credits for it. Okay, so keep doing it. Oh, really? You think so? Okay, I'll give you a couple more days. Let me change the due dates. Well, no one actually complained about that, so that means you're probably not right. I don't know. Some of you do homework ahead of time. So, okay, I'll give you 2 more days, 3 more days, all right? Otherwise, it won't be fair for others. Thank you, Yongxin. Have a good night. All right. Anyone else has any questions?
Oh, I think I got some points lost, homework 6, for late.
That's right. That's right. I have to change it because otherwise it won't be fair. That's right. Let me see chapter 6. So I'll change it for everybody. Because chapter 6, we did cover a lot, so I should give a longer time. Let's see whom I deduct. Chapter 6 is IKEA. Okay, I'm going to give her full credits. Chapter 6, Tom. Oh, yes. All right, 100 now.
Thank you.
Okay. Thank you for reminding me that. Otherwise, I'll forget. Okay, have a good night.
All right.
Okay. Angelique, Catherine. Okay. Bye, Catherine.